Welcome, folks. It is the 27th day of remote learning. I have a meeting for teachers from our school board to help us with some advice on how to determine marks in a semester where we don't really have enough information to properly determine marks. So we'll see what they say, but unfortunately it's at the same time as our usual live stream. So instead of a live stream today, we're going to have a pre-recorded lesson. My apologies for that. On Friday, we'll go back to our live stream at the regular time. And I've also had a request to answer some questions about streaming and my streaming setup. And I believe one of them was, how many stacks do I make from streaming? So we'll do that on Friday. So please join in the stream and come enjoy yourself and learn some math. Two things that usually happen at the same time. All right, so let's jump right in. There are 4 skills for today. First one is equations with variables on both sides. With variables on both sides. So how do we go about solving these? Well, let's take a look at an example here. If we have 5x plus 7 equals 3x minus 5. The key thing to do is to move all the terms with x's to one side of the equation and move all the terms without x's to the other side. So we're going to do that by doing the same thing to both sides and using opposite operations. So in this case, I had positive 3x, so I'm going to subtract 3x, and I'm going to do that to both sides. So opposite operations, same on both sides. 5x minus 3x is 2x. 7 is unaffected. I'm going to leave some space there. 3x minus 3x is 0. We're left with negative 5. And now I have plus 7, so I'm going to subtract 7, and I'm going to do it on both sides. We end up with 2x equals negative 12. Divide by 2, divide by 2. X equals negative 6. So that is the key for solving equations with variables on both sides. It's to move all the x terms over to one side. So you can see I got rid of the 3x on this side, no more x terms over here, all the x terms over here, and then I can combine them with my like terms to get a single x term. And then from there, just a regular finish of the solving. So the second one here is solving proportions. And we have a lot of different ways to solve proportions. If we have something like x over 7 equals 3 over 8, one way that we can do it is we can just treat it like an equation, because it is an equation. We can just say, okay, x divided by 7, well, we don't want that divided by 7, so we are going to multiply by 7, and we can make it 7 over 1, so it's a fraction. And then whatever we do to one side, we have to do on the other. So I've just multiplied both sides of this equation by 7. Top times top is 7x. Bottom times bottom is 7. 7 divided by 7 is 1. So they cancel out because 1 times x is just x. Over here we have 3 times 7, which is 21. 8 times 1, which is 8. And so we end up with x equals 21 eighths. So that's one way to solve it. Another way to solve it, x over 7 equals 3 over 8, is what's called cross-multiplying. Cross-multiplying can take a little bit longer, but it works really well in a variety of situations. So the idea of cross-multiplying is really doing the same thing as here, but to both sides. So we're going to multiply both sides by 7, and we're going to multiply both sides by 8, both denominators. If we multiply this side by 7, it's going to cancel out over here. So multiplying this side by 7 just cancels out the denominator of 7, like we saw here. So that'll be left with x. Multiplying this side by 7 doesn't cancel out, so we have to show the times 7. Multiplying the right side by 8, though, does cancel out. 8 divided by 8 is 1. 1 times any other stuff is just whatever that other stuff is. So multiplying this side by 8 just gets rid of the divide by 8, so that's gone. Multiplying this side by 8 doesn't cancel out, so we need to show it. So we get 8x equals 3 times 7, or 8x equals 21. Divide by 8, divide by 8, x equals 21 over 8. So some people prefer this method. You're welcome to use it as well, whichever one makes most sense to you. One nice thing about this method is that it works well in the situation where we have a variable in our denominator. So let's call that example 1 and example 2. Here we go. So if we have, say, 9 over 5 equals 7 over x. So now our variable's in a denominator rather than a numerator. What can we do with that? Well, with cross multiplying, it's going to be the same thing. I multiply both sides by this denominator, which is x. X divided by x is 1, so it's going to cancel out of this side, leaving me with just the 7. And then over here, I'm going to have 9 times x. Now I multiply both sides by the other denominator, which is 5. 9/5 times 5 leaves just 9. It cancels out the 5. And over here, we'll have 7 times 5. So we'll end up with 9x equals 35. Divide both sides by 9, and we end up x equals 35 ninths. So that is an advantage of the cross-multiply method. It's a little faster if you have your variable in the denominator. If you have your variable in the numerator, this other method is a little bit faster. And you can just multiply both sides by the denominator under the x. So there we go for solving proportions. The third skill that we're looking at is multiplying and dividing powers. So this is our exponent rules. And actually, no, I don't think I have quite enough space there. I just drew in pen on my wall. That's not good. Oh well, we'll deal with it later. So exponent rules. So the first thing is if we have 2 to the power of 3 times 2 to the power of 7, when we multiply two exponents, we add the powers, or when we multiply two powers, we add the exponents. So we'll get 2 to the power of 3 plus 7, which is 2 to the power of 10. If, on the other hand, we are dividing two powers, then we are going to subtract the exponents, 7 minus 3, which is 2 to the power of 4. And if we have power of a power, so 2 to the power of 3 to the power of 7, a lot of people get this confused with the first situation. It's not the same, right? Here we are multiplying the powers, 2 to the 3 times 2 to the power of 7. Here we have 2 to the 3 to the power of 7. So different situations. In this case, we multiply the exponents, which is 2 to the power of 21. All of this stuff works equally well for variables. So let me show you here. If we have x to the power of 6 times x to the power of 2 all to the power of 3 over x to the power of 5, well, we're going to treat each of these powers as if it's a number in itself and follow order of operations. So if I had 4 times 3 to the power of 5 over 6, notice each of these three powers has been replaced by a number. I would look at this and go, okay, what's my order of operations here? Oh, I have to do 3 to the power of 5 first. So same thing here. I have to do x squared to the power of 3 first. So x to the 6. This is going to be x to the power of 2 times 3 divided by x to the 5. And of course, you can just go ahead and calculate that right away, but because I'm doing a demonstration here, I wanted to show each step in detail. So we're going to get 2 times 3 is 6. And then the next thing I would do, well, with multiplication and division in this case, it doesn't really matter what order I do them in, but most people would do the top part first. multiplying two powers with the same base, I'm going to add the exponents, so we get x to the 6 plus 6 divided by x to the 5, and that is going to make x to the 12 divided by x to the 5, and that gets us into our last step, which is doing the division, and we get x to the 12 minus 5, which is equal to x to the 7. All right, so hopefully that helps you through the exponent rules. I think that the practice doesn't actually have this third rule in it, but we will make sure that we get into that later. It's going to be really useful for us in grade 10. By this third rule, I mean the one that's power of a power. Okay. And then our last one is graphing in slope-intercept form. So here we have an equation that's given to us, and we want to draw the graph for that equation. So if we have our axes, x and y, x is always horizontal, y is vertical, and let's say we're given the equation y equals negative 3 over 4x plus 5. So 1, 2, 3, 4, 5. So when we're graphing, we are not focused. There we go. All right, so when we're graphing from an equation, we always begin with the y-intercept, and it's represented by the letter b, which makes it easy to remember that that's where we begin. Y equals mx plus b. So 5 is where we begin on the y-axis. That's my first point of this equation. And then we move according to the slope, and it's represented by the letter m, which helps remind us that we move. The top part of the slope tells us the rise. The bottom part tells us the run. So the top part is how much we go up. Since it's negative, it's actually going to be going down, because if you go up negative 3, that's the same as going down 3. So I'm going to go 1, 2, 3, always starting from that y-intercept. Down 1, 2, 3. And then our run is 4, so I'm going to go 1, 2, 3, 4. And that's my second point there. Usually I'll make a third point. 1, 2, 3, 1, 2, 3, 4. And your 3 points should line up in a perfectly straight line. If they don't, you've probably miscounted somewhere. So you can always check your work by doing 3 points and making sure they line up. And then I can draw my graph. So that's it for today. If you do have questions, I obviously can't answer them in a pre-recorded video, but I'm happy to do them by email. So send me an email, let me know what your questions are, and we'll see you for the live stream again on Friday. Take good care.